Alright, so what is a limit? So I accidentally put this line here when I went and typed everything I wanted to say. I was going to have us fill in the word function, but I already typed it. So a limit of a function is the value that the function approaches as you get closer from either side of that place, as you get closer to a given x value. So what that means is as you get closer and closer to like some x value, your problem's up here doing what it does. So it is basically the y value that the function approaches as that happens. So let's start with this one. Y equals, this right here is your function. So like y equals 2x plus 1. And this is telling you what you're approaching as x goes to 2. So let's draw 2x plus 1. Starts at 1, goes up 2 over 1. So if I draw that thing, it looks like this. Okay, so as I come into 2, from the left, like from the left side, as I come into x equals 2, it goes to the height of 5. And when I come from the right, it also goes to the height of 5. So no matter what I do, it's coming to this place right here. So that's the answer to the limit. It's as simple as that sometimes. And so you don't always have to draw a picture. Like you can literally just like plug in 2 and get the answer. Okay. So the limit is the intended height of the function. Okay? At a certain x value. Right, so down here, so some more scenarios. So remember, we would have piecewise functions sometimes. So look at this one. You have like a cubic function, then it stops being cubic, becomes a line. Over here you have a line, and it looks like a quadratic. Okay, so f of 4. So when I ask you for f of 4, I'm asking where is the function when you're at x equals 4. So remember, we have to look at the black part of the function. This is empty, this is a white part. So like the blackness of the function is right down here at -5. So the value at 4 of the function is -5. But what was I approaching as I came to 4? So from the left side, I was whipping around and I was coming to here. On the right side, I was coming to here. So I was coming towards a -2 height. I was coming towards -2. It just so happens that that's not the answer when I get there, but I was coming for all intents and purposes to -2. So that is the limit. So the limit is not necessarily the value of the function. The limit is where was your problem intending to go. Okay? Like if we were both going to some restaurant and when we got there, the restaurant had moved or like it wasn't there anymore, it had closed down. We were both intending to go there, that's where we were planning to go, but it just wasn't possible. All right, over here, f of -1. So at -1, the black part of the function is here. So the answer is 1. So -1 altogether. So what happens here, I should have reversed this a little bit, but when you start putting this little negative sign right here after, like in the exponent, that means from the left. When you start putting the plus sign, it means from the right. Right. So if you're coming to -1 from the right and left, if you're coming from the left, you're following this, and you're coming to a height of 1. So coming from the left, the height is 1. Coming from the right, it comes around, and it goes to a height of 3. So I can't agree. Like, I don't know, the right and the left side go to different places. So what we say about the full limit is we say it does not exist. Because neither of those is more important than the other. Even though also there's a blackness right here, that doesn't make it more important. The limit is the intended height. If I can't agree on what both sides were intending to go to, then I can't agree. So for it does not exist, we write the letters D and E, by the way. Okay. All right, so let's see, up to the back. All right, here, so this is just your normal like cubic function, 2x to the third minus 4. So you can see at 2, it's like way up here somewhere. But we can also just do this. Hey, guess what? Let's just plug 2 in here. So 2 times 2 to the third minus 4. So that's 16 minus 4 is 12. Okay. 5, this is a cube root function. So instead of squiggling up and down, it goes side to side. But you can literally just plug in 5. Like that's direct evaluation. You're directly just plugging it in. So what? 10 minus 2 is 8. So cube root of 8 is 2. Okay. Here, when I try to plug this in though, when I plug 3 in here, I get 0 on the bottom. That's bad. And 2 times, this is 9, so 18 minus 18 again, also 0 there. This is a situation where you have to do something else. If you get 0 over 0, you have a situation where you have to factor and get something to cancel. You cannot process this. All right, so let's look at this. The top I can take out a 2x, which leaves me x minus 3. On the bottom is x minus 3. So those cancel. So now I have the limit as x goes to 3 of just 2x. And now I am able to plug in the 3. 2 times 3 is 6. So once that offending part, the part that's making you get 0 over 0 is gone, then you can evaluate the function. And you can also see, so basically that's what makes a hole in your graph, right? Back when we were graphing rational functions. You see how this is going towards 6 and this is coming down towards 6? It's going to be 6. That's the limit. The function does not exist there at 3, but the limit can still exist. All right, so here, negative 4, so that's going to be 0 on top. On the bottom, I'm going to get 16 minus 4, that's 12. 12 minus 12 is 0 again. So hopefully if I factor, some stuff will cancel. So x plus 4, x minus 4, x plus 4, and x minus 3. So these cancel, so this is equal to the limit of x going to negative 4 of x minus 4 over x plus 3. So now that offending part is gone, I can actually plug in a negative 4. So I get negative 8 over negative 1. So I get 8. All right, remember, a problem like this is your function. This is your f of x. So f of x equals 2. That's just a horizontal line. Nothing to plug in, nothing changes, it's always 2. So when you plug 5 into this, there's no place to plug it in. So the answer is still 2. If you go to 5 right here, from either side, your height is staying at 2. Okay? All right, so now we get some stuff here. We get some rational functions. This is coming from the left, and I have an asymptote here. So coming from the left, my graph goes up to infinity. Coming from the right, my graph goes down to negative infinity. So the full answer is does not exist, because they do not agree. Over here, though, both the left side and the right side are going up to infinity. So the full answer can be infinity, because they both agree. All right, just some quick questions. F of negative 2 using this picture. So where is the black part of the graph at negative 2? So there it is, 3. The limit as you go to negative 2. Now the limit, you're following the function. It's the intended place. So when you are at negative 2, the graph seems like it's going on both sides down to negative 4. 1 from the left, so 1 is here. From the left, it's a height of 2. From the right, it's a height of 0. So these do not agree, so it does not exist for the full limit, because they don't agree. F of 1, nothing's happening at 1, so it does not exist. These are both empty. There's no black part of the graph there. And f of 4, the black part's here, so 4. And so then you get your homework there. It looks long, but it's actually pretty quick because it's just a lot of pictures.